I write a compiler for a minimal imperative programming language called Elna. Its syntax is Oberon-like or Pascal-like. The compiler is, by the way, written in itself, and it is not finished yet, so a lot of parts are still missing, and therefore I cannot use. So the language I write in is not the full language, but still a work in progress, so I can use all the features of the final language as I understand it. And some important parts are missing, like error checking. It calls then this elnatel global declaration, and it returns this elna_rtl static variable. We hadn't return types earlier, but we have them now, so I can provide a return type for the functions that have one. For example, here as well we have the return type. Return. Oh. Here we already have one. And here we return the variable map, and the variable map is this in a symbol table. Let's try to compile it. The return types are currently not needed. They aren't checked, but we will need them later. For example, here as well. The language itself can have only one return statement at the end. It is the same as Oberon does it, but it has go-to statements if needed. And here we return first copy, which is this one. And here we return first copy. Current declaration is here elna3 declaration, and the result is variable not. And variable not is the thing that is returned from the elna parser variable declaration. So it is basically just elna3 declaration, as it seems, elna3 variable declaration. So we can assign here a proper type. Word is currently a generic type that I use or used at the time that I don't have proper types. Now I can specify the real types of variables. It wasn't always the case, but now we can provide type names. Here we return the first variable, so it is the return type. Actually, I skipped one function that assigned, for example, 0 to this variable. We can replace it with nil. And we can replace this with nil. So here we can see that at the beginning I didn't have, for example, pointers or nil for the null pointer, but only integers. But now we can just compare with the nil, because it is actually the correct comparison. Let us look at other functions. There we can provide the missing return type, probably string length it actually returns bird, and it's fine. Here we return the result. It should be probably a string pointer that we do not have yet. Sulfur, this is Boolean. List append, and we return an element. So basically Elna list node pointer. Here we return the result, but we already have a return type. Elna RTL instruction create, so we create this instruction and we want to return it, and its kind. Elna RTL instruction kind is the thing that is assigned to the operator, and it has the type Elna RTL operator. And I can actually rename it to operator. This is newer functions. They all have the return type already. Instruction kind is Elna RTL operator. This one returns the pseudo symbol, so this thing. And we can actually split it up. And here we return the instruction. So here we return the result of Elna alloc operation target. And its return type is Elna RTL instruction pointer. This one returns the instruction. I think this is actually, this looks wrong. It shouldn't be an instruction module, but it can be that I use the same instruction module for TAC. TAC is the 3 address code. That is actually not 3 address anymore. I probably should rename the functions. Yeah, I do not have TAC instruction module, and I do not have a TAC module, and I use this instruction module for both. So we return actually then the same type. Parser node is nil, and I return it. L03 expression, that looks fine. And here we return this result. Simple expression is actually not a word. Simple expression, it is a word here as well, but we assign the result of Elna parse a simple expression to it. So let us, and it returns this Elna3 expression. So we can assign this type to this variable. And it is also the thing that is, this is wrong. I think that it is a pointer, not the type itself, and it is the same thing that is returned. And it is then the same thing that is here used as argument. So then we have designator, trait expression returns returns nothing. Okay. So let us break it here. And then we have also result variable here. RHS node is actually not a 0. I think it is a pointer. It is a word here, and we assign unary expression to it. Do I modify it anywhere? No, I don't, and we assign it to this LHS variable of the ELNA3 binary expression. ELNA3 binary expression, and it just has expressions as its type, and we assign the same thing to the variables itself. So we provide here proper type and here proper type, and the thing that is returned is actually a binary expression. It is not always a binary expression, it can be also just an expression. I think that I made an error, a mistake previously in the unary parser. But we fix it here first. Now I should be able to compile it. ELNA parser unary expression. So here I return a unary expression, but I think it isn't always the case, because here I parse the designator and return it. So actually result, but I need the result to be a unary expression, so I can access its fields, but at least I can fix the return type and write that it is not always a unary expression, but actually can be just an expression. And the last function that I looked at was the binary expression parser, and we can look for return statements. So here return an instruction, it's already there. Then we have this thing. Let us see how this ELNA parser call is called, and it is also called with this simple expression. So, and simple expression is just a tree expression, so we can fix the argument type, and we can also provide the return type. And I think that this is really the thing that is always returned. Because at the time when we called the ELNA parser call, we already know that it is a function call. It is a bit different for unary expressions and binary expressions. Then we have it a SQL. This line is probably, no, it isn't actually too long. So then we have this one. It doesn't return anything, but I can split up the line a bit. Here we return the results. This doesn't look right. I think the result type is wrong. Aggregate. So Elna parser field access expression, and it gets a simple expression again. So it will be Elna tree expression, and it also has a result. Array expression is called here as well, so this is the same. We have this type as argument, and we return an array access expression. Assign statement. This is the parser as well. Assign statement, and it is called with the result, and result is probably just an expression Elna tree node. I probably do not have a base type for statements. I have a base type for the statements, okay. What was it called? Elna tree statement. And here Elna tree statement, but for example this goto statement, if statement, return statement, label declaration or designator, or a function call. Elna tree statement, and it can point to other statements. Yeah, let us change the type here. I think that statement is more correct here, and that would mean that we pass result is actually here The result is actually here not a statement. I just reuse the same variable because I do not have a type checker. Let us define an additional variable that we call designator, and we say that its type is an ELNA3 expression, and then we assign this one to the designator. On the other hand, call is just an expression, but call is actually also a function call can be a statement or an expression. Expression if it is assigned to a variable, and statement otherwise. But I think that procedure call actually has the same structure as statement, so it should be actually fine to handle it as statement. And here we pass the designator, and if this designator is not a call, then we pass it a statement. But otherwise we just return it as is, because yeah, actually what I need to do is to assign designator to the result, because I know then that it is a call expression, and that it is also a statement. So if it is not a call expression, then it will be some expression, or basically if it is not a call, then it is the left side of the assignment. So now let us go to the parse assign statement once again, and we can assign here an ELNA3 expression and see whether it compiles. It does not. Okay, let us revert it. And do it step by step. So this compiles, then we can remove this thing, and actually, since I do not have type checking, this should be fine. It also should be fine if I change the type of the result, because tree statement and tree node do have the same shape. It means the only thing that actually does not work is the assignment. So we have a tree node. And we want to assign the result of the designator parts into this tree node first. So we assign it here. And then I would say that else the result is designator. Oh, I see. Okay. And now we can replace this type with an expression. So it would be a tree node. And we return the assign statements of this type here. Then we have this return statement. So its type is this. Returned is actually probably an expression. Do I actually have a type for expressions? Yes, I do. Returned is actually not a node but an expression, and it would be also the correct type for the things like Elena parts binary expression. It's the type is correct here. Is it also correct for unary expressions? So here we have these nodes. Yeah, these are expressions and designator, but the designator should also return an expression. This is fine. And tree return statement. Okay. Then we can continue. Then we have TIC, write label. And three conditional statements. Okay. Here is the result tree if statement, and it is the thing that is returned. What is an entry? It is definitely not word, because I dereference it, but it is actually an array of 3 words. And it is probably assigned to this member start. And member start is assigned to result members. Result is an enumeration type expression, and members is really not typed. So what do I have here? I have a start and length, and probably a reference to the next element if this is a list. Start length. Exactly, and we assign 0 to the next element. -8. And here I assign the last element to the previous entry, the pointer to the next entry. Yes, it is a list of strings. Let us define actually a type for it. So here we have this ELNA 3 enumeration type expression. And we have this members thing. It's almost the same ELNA 3 field. And I use it in the record type expression. And this one would be something like ELNA 3, probably just enumeration, and it is a record. It has a name of type word, it has length of type word, and it has a pointer to the next element of type word. I think that I cannot, inside a type, I cannot reference to the type itself. So actually the type of this next should be a pointer to elementary enumeration, but I think that recursive types won't work yet. This still has to be done later. So, and if we define this type, then I actually can replace this magic 12 with the size of this type. And this should still compile and pass the final test afterwards. And now we can assign a type to this variable. It will be a pointer to LN3 enumeration. And this would give us access to the fields of this record, but I should look that I do not break it. So the assignment to the first, we actually can just adjust the pointer here to do it stepwise. So I dereference the entry and assign the start to the name. So it is the name pointer. Then we can remove this thing, and to make it compatible with what I had, I can just add 8 here at the end. Name, LN3 enumeration, LN3 enumeration pointer here, and we allocate it, and name is basically the first member. Oh, if I assign 1 to it, then I advance the thing by the size of the pointer. Okay, we probably will try to rewrite it at once. So this nil, we assign the next nil to the next element, and memory start is the entry, so this is the first entry. Otherwise, previous entry next is current entry, and then we assign previous entry is entry, and then we reallocate entry again, previous. Okay, and then we need the type of the previous entry, of course, otherwise we cannot access the fields, and the memory start will be actually the same thing. Yeah, now it works. Here we can assign. Do I need this memory start at all? I return the result always, so I can probably just use the members. And I do not think that. So here we do have a loop. That means that we need to allocate this thing before we go into the loop. Let us copy these two assignment statements and put them into the beginning. And then we can replace this memory start with result. Actually, an enumeration always has at least one member, I think, or should have. So if we do not allow empty enumerations, then I do not have to initialize this memory start, but I still want to distinguish here. Okay, let us assign nil to the members field, and then the first usage of it is here, and we can check if it is a nil. If it is a nil, then we assign the value of the first member to it. Otherwise, we assign it to the previous entry, and then we assign entry to the previous entry, and this one can go then, and we need to assign the count, the number of the elements at the end after we parse the whole enumeration definition, and this actually should be fine. So we can now remove this memory start variable, and we will only keep the member count. I do not need it as well, because I can just increment the count member. How it is called? It is called length, probably. Yes. So we can also replace this member count. I can assign. I can say that the initial length is 0, and then I can add 1 to it each time we encounter a new enumeration value. And then I do not need this stuff here, I suppose. Then we do not need this. Entry length is token length, or it is name length. That's it, I think, for this function. And now we can say that we return this type, this pointer type. This is actually almost the same. But here it is just an array of strings, and I want to write it later. So the strings, as I see them in the language, will be aggregate types that will be actually almost records that keep the name and the length of the string. But I do not have this string support yet, so we will keep the point arithmetic here until we have strings as I want them. Let us do a test compilation. Here we return this pointer. Then we have this array type here. And here a record type. Okay, this one can be rewritten as well, but we already have the field type here, so I use it for the allocation. But I do not use it as variable type. But it isn't actually the parser, but I already use it for the array current. But yeah, so let us assign it to the start. Memory start, memory count, member array start, and member array count. So we probably use the same shape as in a type field. And here, okay, I already used the fields. For the assignment, and here I reference the memory start, and memory start is the parser node members. Parser node is elnode3 record type expression, and members is actually an elnode3 field. Oh, I see. we have Elna type field and Elna tree field. Elna tree field probably has this next thing, and Elna type field, okay, looks a bit different. What does this mean in this case? So we allocate here not the tree fields, but the type fields, and I assign values to them. And this is true for the members array start and member array current. But for the memory start, we can also use the pointer to the Elna tree field, and it will probably break the compilation because the pointer arithmetic won't be correct anymore. So the compiler crashes, meaning that here, so let me find the Elna tree field once again to see what do we have here. And the first member is the name. The second member is the length. Then if we access the memory start here, then we access the type expression. And then we access the next element. So that means that we assign the next to the memory start. So that we go to the next element of the list, and this actually should be fine. Okay, let us see what variables we do not need anymore. So memory start is not, do we need this member count? What is member count? Here I subtract 1 from it so that I can see how many fields do I have, so we can probably keep it as is, or we can also increment the member array, the size here, and check that it is smaller than the parser node length. And then we would add one to it. Size is actually not the amount of elements. Size, as it seems, is the type size probably. And length is parser node length. So let us put a comment around it. And in each loop we will add result length is result length plus 1. I probably do not have to keep the list length. but no, I need the list length for other passes. So we have +1 here, and that would mean that we need to set the length originally. Basically here set it to 0. It could compile. And then in this loop we can just compare that result length is smaller than parser node length. Then it actually seems to work. That would mean that we can get rid of member count. Yeah, for example, we need the list length here so that we can allocate the array at once without reallocating to change its size. But was it member count? So we do not need the member count anymore, and all other variables are actually typed, I think. So the alignment and stuff is assigned later. I do not actually know. Okay, member start, I need to assign it later to the members variable. And we can assign the kind right away here, and we do not, or memory start, but we can assign the allocated memory to this members thing right away. So we just replace this variable with this. Exactly. Then memory start, and memory start is not the best name anymore. So memory start will be renamed to tree field. Memory start will be renamed tree field. Let us test it. And member array current is kind of okay. Okay, this function is done as well. Then we have this one, it is the parser as well, so we can add the return type here. Then we have this function. So result is a word here, but actually we parse expressions here, I think. Not expressions, but the type expressions. The problem is that I do not have a type for the type expressions, I think. ELNA3 type expression. But the most generic type is actually a tree node. Type decoration, type expression, and I type it as ELNA3 node. So let us return the ELNA3 node here and also assign it as type to the result variable. What is the result here? Does it have a result? Yes, it has a result. Oh, it returns the type for the symbol table. ELNA type basically, I think. Yes. It returns an ELNA type pointer. Then we return this result here, and our argument is type representation type info create. It is called with type info, for example, and type info is untyped here, but it is the result of, and it isn't assigned to itself. ELNA name type expression will return, okay, all types of the symbol table are put in a type info object. We actually need two variables here. I think that I do not need this type name anymore, because this type name is actually parser node, and I do not modify parser node in the name analysis pass, so I can probably replace the variable with the field access directly, and the same goes for the length. So I can probably just remove these two variables that I do not need anymore. And it doesn't work. because I reassigned the parser node here. Yeah. Okay, now we can replace the length once again and try to remove these two variables. This is fine now. Type info is okay, but we will define an additional variable that will be called type expression, and its type will be, oh, it is not a type expression. This is type representation for the symbol table. Let us call it symbol type then, and it is a pointer to an ELNA type, and we assign a value to it here and pass it to the type info create. And type info is basically type info create returns this thing here, and we can pass it then into here. This is fine, I think, and the procedure does not return anything, so that we can just continue if it compiles. This is the result. What is actually word type? What is the word type? Oh, it is a global variable word type. This is also ELNA type, I think. Word type, yes, it is a pointer to an ELNA type. So temporary type is actually an ELNA type pointer, and the attributes temporary info create, just one. Okay, and we do not return anything from here. Then later, but we, okay, here I assign the return type. Here we have a return type. Here we do not. Parameter count. Here we return the parameter list. What is the parameter list? Parameter list is a word but I doubt that it is true. So we okay, this is a string array again, so we cannot type it, but the most generic type is a word array. And now I think we are where we started, so the further functions are probably already handled. Let us just look for the return statements, but from the end of the file. And then when we see the Lexa functions that already have a proper types set, so this should be fine. Yeah, I would say let us do a pause here. So stop here for today. We actually fixed the types of some arguments and added return types. As I said, when I started the compiler, there were no return types, and always and everything was very dynamic. It is the case. It is a case still in a lot of places, but the type informations are used for some things here, like field access and arrays and things like this. And I will need to add the type information anyway to implement the type checking, because the compiler should type check itself. So, and we already did a lot of work for it today, and did a step further. So even if I cannot use this information now, it will be useful later, and it will do us light work later, because we will need this type information like return types and such later. And we also modified some functions, so removed some old code with point arithmetic that can be replaced with the features that were implemented in the previous stages. And I will leave it here for today and look what I do next.